Hi everyone, today we're going to be talking about how to graph quadratic equations. This is the first video in the lesson, and this whole lesson is about quadratic equations. The quadratic equation just has the highest exponent as a 2, so it's got that x squared somewhere. That's how it's shown algebraically. And so that's what we're going to be dealing with this entire lesson, but the first video is all about graphing. So when we graph a quadratic equation, it looks like a parabola, and these two things, this one right here and this guy right here, are both parabolas. It could look like either of those. So the first picture of that parabola is like a U-shaped graph. And so I can keep it right side up, I can flip it upside down. All of that is considered a parabola, which is an x squared graph. And I also labeled the vertex on both of these. So the vertex is just where it changes from increasing to decreasing or decreasing to increasing. And that's kind of the way we're going to move these graphs around. So this whole lesson, we're going to kind of start with a regular x squared graph, which I'll graph soon. But then we can shift it up, down, left, right. We can make it skinnier. We can make it fatter. We can do a bunch of things to it. So a regular x squared graph starts at 0, 0 on your graph. And then because it's a U shape, we can't just have we go up 1 over 1, up 1 over 1, up 1 over 1. We can't have the same slope on each side. Instead, there's this rule, and I like to call it the 1, 3, 5 rule, where I go up 1 and over 1, and then I go up 3 and over 1, and then I can go up 5 and over another one. And each time I go up 1 or up 3 or up 5, I'm going from the last graphed point. Now, if I continue that, or not continue that, but if I reflect that over the y-axis, then I'm going to have that U shape that I'm looking for. And that's just a regular x squared graph. I know I didn't do a great job at graphing that, but with actual graph paper, you should be able to do it just fine. So this is a normal x squared graph. And like I said, we're going to kind of shove it around, up, down, left, right. We're going to make it taller, skinnier, fatter, wider. And all of that is done based on certain numbers in your equation. So before we get started with the examples, there's one other thing I wanted to talk about. There's two different ways that we can represent a parabola, or there's two different ways that we're going to represent the parabola in this self-check. The first way is with standard form, which is right here. That's y is equal to ax squared plus bx plus c. In standard form, there are no parentheses. You can clearly see that there's that x squared there that shows you that it is a quadratic equation. The second example, or the second formula we're going to use, is the vertex form, which is y is equal to a times x minus h squared plus k. In this case, this is something that we've actually seen a little bit before in the transformations of functions lessons, where your h and your k are moving up, down, left, right, and then your a that's in the front of the parentheses is making it taller or fatter, wider, shorter, all of the above, depending on what number that is. So we'll see both types of equations in the self-check, and let's start going through the examples to kind of determine how you deal with both of these. So the first example wants us to graph the equation y is equal to 2x squared. So I consider this to be in standard form because there are no parentheses. And when a graph is in standard form, what we want to do is first find the vertex. So to find the vertex, the general formula is x has to be equal to negative b over 2a. Where if you remember, your a, b, and c are coming from here. So your a is in front of your x squared, your b is in front of your x, and then your c is the constant. And then your y is when I take my original equation and plug in negative b over 2a for my x. So in this case, it'd be like 2 times negative b over 2a squared. And it's 2 times that squared, mostly because the formula is 2 times x squared. So let's go through and find the vertex. So in this case, your vertex is negative b. So, we don't actually have a b, right? There's no portion of this equation that has just an x. So when there's no b like that, I could write it as plus 0b. because 0 times anything is 0, which means that it just cancels out, right? I could potentially cancel that out. But that also means that b is 0. So I'm going to have negative 0 over 2 times my a, which is 2, which is simplified down to negative 0 over 4. Now, negative 0 over 4 is just 0. Potentially, we could have kept the negative on there, but 0 doesn't have any signs. It's just a 0, so my answer is 0 right there. Now that I know that my x value is 0, what I can do for my y value is just replace that negative b over 2a with 0, or what my x would be. And so when I plug that into a calculator, I'm going to have 2 times 0 squared, which will give me 0 again. What that tells me is that my vertex is equal to 0, 0. So I know that when I graph this, I'm going to start, that was a bad graph, let me try that again. When I graph this, I'm going to start at 0, 0, right here. Now, the other things that we have to consider, once we find the vertex, the only other thing that I want you to look at in standard form is the very first number, or your a. In this case, a is equal to 2, right? Because that's the number in front of the x squared. Because a is equal to 2, my 1, 3, 5 rule that we were just talking about turns into a 2, 6, 10 rule. If you notice, I just multiplied all of those by 2. And the reason why I multiplied it by 2 is because a is 2. So when I'm dealing with this, when I have a number for a, I have to multiply my 1, 3, 5 rule by that a. So instead of going up 1 over 1, up 3 over 1, up 5 over 1, I'm going to go up 2 over 1, up 6 over 1, and then potentially I could go up 10 and over 1. I'm not going to have enough space, so I'm not going to do that, but I can reflect the points on the other side, which will give me this parabola. And I know you can't see it very well on mine, but it is skinnier than just the normal x squared graph. It'll make it a little bit skinnier. So that's how we graph that equation, the y is equal to 2x squared quadratic. So now let's look at the next example. The next example is in vertex form, which is y is equal to x plus 3 squared plus 2. Now, the things that we need to remember on here are, I'm going to just rewrite the vertex form, which is a x minus h squared plus k. The big thing on here that we need to know is that h comma k is my vertex. So the number inside the parentheses with the x, and then the number on the outside of the parentheses that's on the very right side, or the thing that's being added or subtracted to the parentheses. And if you remember this from the transformation of functions lesson, the number on the inside always has to flip-flop signs. It's just kind of a rule, mostly because the formula has an x minus h in the inside, and so it just flip-flops signs. So my h in this case is a negative 3, because I'm flip-flopping the signs. It's a positive 3 right, like in the equation, but I'm going to make it a negative 3 for my vertex, and then my k is equal to 2. So my k doesn't have to change signs or anything. We just leave it as is, which means that my vertex is negative 3, 2. So because my vertex doesn't start at 0, 0, it won't change necessarily anything, but I'm going to just start at negative 3, comma 2, and this is where my vertex hits. So then I'm going to look at for this a, because that a, even though this is a different form, it'll still tell me what I do with that 1, 3, 5 rule. In this function, there's no number in front of the parentheses. When there's no number in front of the parentheses, we're going to just assume that it's like there's a little imaginary 1 right there. So I'm going to put a little 1 right there, which means my a is 1. So the 1, 3, 5 rule is just multiplied by 1, which is, again, just 1, 3, 5, because 1 times anything is itself. So from this point, I'm going to go up 1 and over 1, then up 3 and over 1, and then up 5 and over 1 if I had space. I don't have space. Then we can reflect it across, like kind of move over to the other side and do the same thing. And then we get this parabola. So it looks exactly like the x squared graph. We just shifted the vertex over. Okay, let's look at the third example, which is also in vertex form. It's y is equal to negative 2, x minus 2 squared plus 1. So once again, we're going to start by finding our vertex. To find the vertex, we're going to use this number that's inside the parentheses and then this number that's on the outside of the parentheses. But if you remember, the number on the inside of the parentheses has to flip-flop signs. So instead of 2, we know our h, or instead of negative 2, we know our h is a positive 2, and then our k doesn't have to change signs, it's just a 1. So that tells me that my vertex is 2, 1. All right, now what we're going to do is look at the a value, and the a value is the number right up front that's multiplying the thing inside the parentheses. So in this case, it's a negative 2. And the a value changes the 135 number, so 135 will be multiplied by negative 2, which gives me negative 2, negative 6, negative 10. What that tells me is that instead of having a parabola that's like a U, it'll be an upside down U, because instead of going up 2 and over 1, I go down 2 and over 1 because it's a negative 2. So let's start by graphing our vertex. Our vertex is 2, 1. So this is kind of where we start. Then from there, from that vertex, I'm going to go down 2 and over 1. Then I'm going to go down 6 and over 1. And potentially I could go down 10 and over 1. Then I do the same thing on the other side. Sorry, that probably should go a little bit more like that. And now I can connect all the dots. And here is my graph. And it's that upside down U because that A is negative. All right, let's look at that last example. The last example, again, is in standard form. So it's y is equal to x squared plus 8x minus 2. So I'm going to start with my x value coordinate of the vertex, which is, the formula is negative b over 2a. So in this case, it would be negative 8, because that's my b value, over 2 times my a. So there's no number in front of that x squared. When there's no number in front of the x squared, we're going to consider it to be a 1. Remember, because I can always put a little imaginary 1 in front of anything. So when I simplify that, I'm going to end up with negative 4. So that's the x portion of my vertex. To find the y portion of my vertex, I'm going to just take my original equation and replace all of the x's with negative 4. So instead of saying x squared, I'm going to say negative 4 squared plus, instead of saying 8x, I'm going to say 8 times negative 4 minus 2. Notice that I put the negative 4 in parentheses. You want to make sure that you do that, particularly if you're planning on using a calculator. The calculator sometimes can't read what you want to happen unless you're very specific about it. So you want to make sure you put those numbers in parentheses. So when I simplify that, I'm going to have 16 minus 32 minus 2, which gives me a negative 18. And so my vertex in this case is negative 4 comma negative 18. Now, I don't know if you have space on your graph to actually draw that. I don't think I gave you 18 spaces on the y-axis, but maybe just try and draw it down a little bit further so you can see what's happening. And then the other thing we're going to check on is the a value. So we kind of talked about it, but there's no number in front of the x squared, which means your a is 1. So the 135 rule stays 135. So when I graph this, I'm going to try and do a pretty good job. It would be negative 4, negative 18. I'm not going to draw, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so here's my vertex, which is at negative 4, negative 18, and then it's going to follow the 135 rule, so it'll kind of look like this. And there we have it. This is how we graph quadratic equations.